if they tell you you have a cosecant, that means that you are basing your graphs on the sine. Okay? And you can start at any asymptote. Okay? It doesn't matter which one you start at. Okay? So the way that I would approach this here is I would identify sort of the max and min of my reference graph. So between 9 and -1 is a total distance of what? 10. Cut that in half. That gives us our asymptote, the asymptote of our reference graph, and also allows me to move up 5 or down 5 to find where my midline is. I'm just going to draw a solid line here. So y equals 4 is my midline. Okay, and so what I can do is if I look and I can start at any of these asymptotes. So I can see that one asymptote goes right through 0, right? So that would allow me to not have to deal with any horizontal shifting. So I'm going to start there. So if I pick this as my first point, I can see that it goes down and then back up, max, midline. So the sketch of the graph for my reference is right here. So this is one period of my sine function that's used as the reference for that. And so that's all I'm going to need in order to calculate or find the corresponding equation. Okay? Because I'm going to go ahead and find what this equation is right here. So I'm going to take y equals, or I'll use what they asked me to here, f of x equals. So my period, the amplitude is 5. And I'm going to use sine here because it's the cosecant is what I'm looking at. And I'm going to take, I'm going to fill in my middle part in a bit, but I do see my vertical shift is +4. Okay, now because of this, the direction of this period here for sine, is it going to be a positive sign or a negative sign? It goes down first, so it's a negative. So I'm going to have a negative out front. Okay, and so all I need to do here is find out what's in front of my x. Again, there's no shift, so I don't have to worry about adding or subtracting anything. So if this is my period, I see that my period is from 0 to 2, right? So if I take 2 and I set it equal to the equation for my period, which is 2 pi over b, I can now solve for b. So if I multiply both sides by b to get that out of the denominator, divide by 2, that gives my b value is pi. So there's my multiplier in front of x. That's all I need to do. The only thing left to complete this is to change this into the reciprocal cosecant of pi x plus 4. Okay? This is not the only way to write this, but probably the easiest or quickest and easiest way. Okay? Now, if you only wanted to work with positive sine and positive cosine, what you would have to do is you would have had to shift over here to start with. So then you would have gone up, down. So you would have used this as your one period, which is fine. Okay, we could have done that as well. If we had done that graph in blue, our amplitude is still 5. I'm going to use sine to start with. Okay, and now it's a positive 5, so I can leave the sign out in front positive. But the difference here would be you'd still have pi as your multiplier in front of x, but we do have a shift. So inside that, we have pi times this whole quantity of x, and to represent the shift over here, from 0 to here is a shift of minus a -1. And so if that was the equation, or if that was the portion of the graph that we wanted to identify the equation for, we would come up with the form in blue. Either one's fine. Oops, just change this to cosecant. Okay, and that would be your solution. Either, again, and there's multiple answers for that. On something like this, you can kind of see here this relative min right here is halfway between -3 and -4, but the vertical asymptote passes right through the integers. So I would probably think I'm going to use the sine as my reference graph for this. Now, it's also very likely that it'll tell you specifically what it wants, but you can do it on either. if the conditions are right for both of them. Okay, so the way that I would approach this is first again, take your max and min, look at that total distance between -4 and 8 is a distance of 12, cut that in half, you get 6. So there's the amplitude of your reference graph. So we'll go up 6 or down 6, and we're going to get our midline. The midline we see is at y equals 2. Once you have the midline, right, and your amplitude, you can start your equation. So we have f of x is equal to our amplitude of 6. We're going to do cosecant, so I'm going to use as a reference the sine. Don't know what's inside yet, but I do know plus 2 is on the outside. Okay. So the next step is to locate on the midline where the midline intersects the asymptote, where you want to start the period of your sine graph. Okay, so let's say I want to work with a positive sine graph, because I'm shifting no matter what. If I had an asymptote right on 0, I'm not going to shift, and I'm going to use a positive or a negative. But if I have to shift, it's probably easier just to stay with the positive. So I'm going to shift all the way over here. Okay, and so I'm going to start with this point. I'm going to go up to maximum, midline, minimum, midline. So this right here is my one period of my sine graph. Okay, so what I did was I used the positive sign, so I'm going to leave my 6 a positive here. Okay, I am going to identify what the total period is. From -5 to +1 is a period of what? So the period equals 6. So I'm going to set 6 equal to 2 pi divided by b and solve for b. So multiply both sides by b, divide by 6. I get pi over 3. So that is my multiplier in front of x. And remember, that becomes the whole multiplier inside. And I could just treat it as x minus my shift. And my shift here, I moved it 5 units to the left, so minus a -5. And so the way that I use this reference graph right here, I created this equation. And so if I'm converting this into my cosecant, I get +6 cosecant of pi over 3 times the quantity x plus 5, all plus 2. Okay. Now, once again, I like to show options on this. So if instead of shifting to the left, if you wanted to shift to the right, and we started here, okay, we would go midline, or actually, let me shift just so that we just shifted 1 unit over. Okay, we go midline, max or minimum, midline, maximum, midline. So if this was the case, if we chose that point, then the graph that we'd be finding the equation for would be this sine function. And if that was it, we would have same amplitude 6. I'll write sine, but I'm going to cross that out. But it's now a negative sign, so a negative in front. My period's still pi over 3. The vertical shift is still plus 2. The only difference here would be that instead of shifting all the way over 5 units, I'm going to shift 2 units to the left, so x minus a -2. So this would be another alternate form, cosecant. Okay, so both of those equations boxed in would be correct for this problem.